Okay, so today we're going to be talking about section 8.5, solving systems of inequalities by graphing. We're going to skip the warm-up. We're not really worried about, quickly we can say the difference between a system of equations and inequalities. An equation is going to have an equal sign. An inequality is going to have an inequality symbol. So we've got greater than, less than, greater than or equal to, and less than or equal to. Okay, so we probably should be familiar with all of these. So a system of linear inequalities are two or more inequalities. So if you look at all of the examples down on this page, you have multiple inequalities that we're going to be graphing. So a solution is an ordered pair that is a solution to both inequalities in the system. Now we're going to see that there's not just one solution necessarily, but an entire region. So let's start by looking at our first example here. So these are both in slope-intercept form, which is great. I can graph my first inequality. So I've got a y-intercept of -1, a slope of -3. So I'm going to go down 3 over 1. I always like to have multiple points just to get a more accurate graph. Okay, and I'm going to take my straight edge. Now, I'm actually going to move back up for a minute. So when we talked about less than, greater than, or less than, those would always have a dotted line as the boundary line. And if we have an equal to, that means any point on the line also works. So it is a solid line. So in this particular case, because I have greater than or equal to, I'm going to draw a solid line through these coordinates. And we're still not finished. The one thing with inequalities is that we're not just graphing the line, we also need to shade either on one side of the line or on the other. Now, in order for us to figure out what side to shade, I don't like to use any tricks here. I like to do the same thing every single time, and that's to test a point. So if I want to test a coordinate, usually I like to choose a point that's easy to plug in. So let's say 0, 0. You'll notice that 0, 0 is on the right side of this line. When I plug it in, I'm going to put 0 in for y, 0 in for x. You guys are going to find some shortcuts here. Like, for example, if I plug 0 in for x, this whole part should go away. So I'm left with 0 minus 1, which is -1. So we want to ask, is 0 greater than or equal to -1? And in this case, it is. So that means that this point is in the shaded region. So we want to shade the side containing 0, 0. Now, I like to use pencil here, at least until we get to that final answer. Okay, so for now, I'm just lightly shading in. You could go a little darker if you want, or shade the whole area kind of lightly. We're done with that first inequality. Now we need to jump to the second inequality. So my y-intercept is 2. My slope is 1, up 1 over 1. And in this case, I'm going to have a dotted line. So I'm going to draw a dotted line passing through these coordinates. The straight edge is really helpful here. I strongly recommend that you guys use an ID, a ruler, the side of your calculator, something. Okay. Now I'm going to test 0, 0. Okay, so I put 0 in for y. 0 plus 2 is 0. Now, is this a true statement? 0 is less than 2. Yes. That means, now if I'm looking at this pink line over here, 0, 0 is like underneath it, right? So I'm going to shade underneath the pink line. Now our solution region is going to be where the shadings overlap. So you'll notice that they overlap in this area here. I like to go a little bit darker once I know where that overlap is, just so I can clearly tell where that solution is. When you guys are doing your homework, you should clearly mark the final solution region. Okay, so if we go back to our definition of our solution, it's really a region of points that work in both of the inequalities. So if I pick any coordinate in this shaded area and plug them into both, they will be true. Okay. Now, if I jump to example 2, these are not in slope-intercept form. That's okay. I'm actually going to show you guys a quick way to graph these, even if they're not in slope-intercept form. Okay. So if we want to find the intercepts of this first equation, remember that an x-intercept is on the x-axis, right? That means that the y value is 0. So I'm going to use something called the covering up method. Cover up method. I may have shown this already earlier in the year, so if you already know, great. If not, we'll do it together. So that means that if you cover up the y value and solve for x, you'll get the x-intercept. Okay, so let's just write that down. Cover up y and solve to get the x-intercept. And likewise, we're going to cover up x and solve to get the y-intercept. A lot of times this method is going to be a lot faster for us than rewriting in slope-intercept form and then graphing. It just saves some time. So if I want my x-intercept, I'm going to cover up this y, and I get, it's kind of hard to see, x is 7. So that means my x-intercept is 7. If I plug 0 in for x, okay, so the 0's here, pretend like this is an equation. We're basically ignoring the fact that this is an inequality. If I were to solve this for y, I would get -7. Okay, because really it's negative y is equal to 7, divide by -1, gives me 7. So now I'm ready to graph this. If you would rather rewrite into slope-intercept form, totally fine. Go ahead and do that. I just think this is faster. Notice I didn't even have to do any work. Everything was in my head. And if I test a point, so let's say we're going to test 0, 0. 0 in for both of these gives me 0 is greater than 7. Well, this is not true. That's definitely false. Now 0, 0 is above this dotted line. That tells me we're going to shade below. Actually, let's do lighter. Let's just do something like this. So we're going to shade the other side of that dotted line. Now we're ready to move on to the second inequality. The y-intercept, cover up the x, is 8. The x-intercept, cover up the y, divide by 2, I would get an x value of 4. Again, rewriting this in slope-intercept form will give you the exact same equation. So again, I'm going to have a dotted line here. Okay, I like to ignore the blue stuff, try to pretend like that isn't there. And we're going to test 0, 0. Plugging 0 in for both of these gives me just 0 is less than 8. And this is a true statement. So we want to look and see, okay, 0, 0 is on the left of the pink dotted line. So I'm going to shade to the left of the pink dotted line. And we see that our overlapping region is in the bottom section here. Okay. Let's do one more together, at least part of it, just so I can show you a different type of equation. Remember that when you have just one variable, if, let's say, for example, I had x is equal to 0, that is a vertical line. X equals is always vertical, y equals is always horizontal. So let's start with this vertical line, and it is solid, going through 0 on the x-axis. So this one is x equals 0. Now, if x's are greater than 0, well, greater than means the numbers are bigger. So I know I'm shading to the right here. I don't even have to test a point. X values are greater than 0 to the right. Okay. Likewise, y is greater than 0. Well, y equals 0 is a horizontal line. So we're going to draw this horizontal line. Greater than means we're shading above this line. So far, my overlapping region is over here, okay? Now, I still have one more equation to work with. And again, you can use the intercepts if that's easier for you. So I'm gonna find the y-intercept by covering up the x. So my y-intercept is positive 8, because we're dividing by 3. 1, 2, 3, 4, 5, 6, 7, 8. The x-intercept, cover up the y. It's kind of hard to do that, there we go. Cover up the y, we would get an x-intercept of 6. Just a much faster way of graphing. And another solid line here. Okay. And so now we're going to test a point. So if I put 0, 0 in here, 0 is less than or equal to 24. That's true. So 0, 0 is basically on the left side of this purple line. Now our overlapping region is this closed little figure over here. Okay, now technically there's still an infinite number of points in here. There's an infinite number of coordinates because we can have some decimal values. We call this a bounded region in case that comes up. And something like what we have up here is called an unbounded region because it goes on forever. Okay, so you guys can go ahead and pause the video and try example number 4 on your own, and I'll put the answer up in just a minute. Okay, so here we have a solid line. The blue one is actually our top inequality. I rewrote it in slope-intercept form. It was a little easier. Our second one, you could rewrite in slope-intercept form, or you can just use the original. It's the pink dotted line. And then we have a vertical line. Okay, so after we do our shading, we end up with this triangle bounded region. All right, so let's jump to the next page. I have a word problem here. To be honest, I will skip this problem. I'm not going to be giving you guys word problems on the quiz on Friday. I will work it out in case you're interested to see what it looks like. But for now, we'll just leave this one alone. Okay. But I will jump down to the follow-up question because we can still answer it. So how many solutions does a system of linear inequalities have? Now, when we have something that looks like any of the problems that we just did, so let's say it's something like this, shading below, something like this, shading above. Okay, we have this bounded, unbounded region actually. Whether it's bounded or unbounded doesn't matter. notice that there are an infinite number of points here. So we would say infinitely many solutions. Because the question is how many points overlap for one function to the other, from one inequality to the other. Now, if I had something like this, let's say I had a vertical line, and let's say its x is greater than, we'll call it 2, okay, or greater than or equal to. So I would shade to the right, okay. Now, what if I have another inequality, x is less than or equal to negative 2? Would look something like this. If we're looking to see how many points overlap between these, there aren't any. This would be a situation of no solution. Okay, it's not often that you see situations like this where shading is in total opposite directions, but if you do have something like that, there are no overlapping points, so it's no solution. Okay, now our last set of problems here are nonlinear inequalities. And actually the process is exactly the same way. We just need to graph, instead of just a line, in this case I have a parabola as well, okay? So the process is going to be exactly the same. Graph it as if it were a function, as an equation, okay? Test a point, and then do the same thing for the second inequality. So my first equation, let's say I wrote this as y equals x squared minus 4. This is a parabola, right? A quadratic. So the minus 4 tells me I'm shifting down 4 units, but if you're unsure, or let's say you forgot how to graph, make a table of values, okay? So if I make a table of values, I want at least 5 points for quadratics. Okay, these are usually good starting points for that quadratic. I will probably give you guys pretty simple quadratics to graph, so not a lot going on. Something like this would be perfect. So if I plug in negative 2 squared gives me 4, minus 4 gives me 0. Okay, and I would repeat the process. Use a calculator if you need to. But I'm just going to fill in the table. Okay, now when I plot these points, I've got negative 2, 0. My next coordinates are coming here. Now this is going to be a solid line. And in this case, a solid curve. So we're going to try to go through the whole graph if you can. Just kind of extend out each side, something like that. Now we still need to test a point. So I'm going to test 0, 0 in the original inequality. So I've got 0 is greater than or equal to negative 4, which is a true statement. So that tells me that my shading is on the side of 0, 0, which is inside the parabola. So we're done with this first inequality. Our next one is going to be the linear inequality. Now, I'm going to rewrite this in slope-intercept form just by moving the x over. Divide by negative 1. One thing you need to remember is that if you're dividing by a negative, we have to flip the inequality symbol. So we end up with y is less than or equal to x minus 2. So go ahead and use your slope. Okay, I've got a solid line here again. Something like that. And now I'm ready to test a point. If it's easier for you to test in the original inequality, look how easy it would be to put 0, 0 in here. So if I put 0 in for x and y, I end up with 0 is greater than or equal to 2. Now that is not true. That means that 0, 0, which is above my pink line, is not going to be in the shaded area. The shaded area would have to be below the pink line. And so now you can see that the overlapping area is just this little bit over here. Okay, so you'll see different types of functions. In this case, we had a quadratic. If it helps to use your calculator, feel free to do that. Okay, so if you want, you can use your calculator as long as you use points. That's from the table function in the calculator. I'll remind you guys how to do that now. So if we were to put this into our calculator, I'm going to clear out all this old stuff, don't need that. Okay, so if I have x squared minus 4, okay, I'm not worried about the inequality part, I'm just worried about the table. To be honest, I don't even care about the graph that much. If you go to second table, you can use this as your table of values. Okay, you might need to kind of scroll left and right just so you have enough points. And there you go. Okay. Now our last problem here, same idea. We've got a trig function now. So I've got 4 sine of x. Now just for our purposes, I think, let's see here. Let's do this. I'm going to mark the x-axis going up to 2 pi. So we want 4 tick marks. I'm going to call that 2 pi. And we'll do the same thing going to the left. 4 tick marks, negative 2 pi. Okay, remember that when we do a cycle of sine, it's always going to be 4 tick marks that you use for that whole cycle. So sine starts at the midline. We go up to a maximum using that amplitude of 4. Okay, back to the midline, down to the minimum at negative 4, back to the midline. So I have this curve, something like this. And I can keep going if I want to. And I want to keep going on the left as well. So just follow the pattern and curve through your points. So again, use your calculator if you forgot what the shape looks like, but we have something like this. Now shading, I cannot test 0, 0 because it's already on the line. I need to test a point not on the line. So let's just test an easy point, something up here. How about 0, 7? Right up top. So if I were to plug 7 in for y, greater than or equal to 4 sine of 0. This is where your calculator is going to come in again. Okay, so I'm going to do 4 sine 0, and I end up with 0. Okay, so I have 7 is greater than or equal to 0, which, yes, is true. That means that my shading is going to be above this whole curve. Anywhere on the curve, so just basically above the whole line. Okay, now our second inequality is a horizontal line. Y is less than 2. So let's see, 1, 2. We're going to have a dotted horizontal line. Less than means we're shading below. So I'm going to just lightly shade below. And you can see that the overlapping region is in these little dips. So we have multiple sections here, and they would go on forever. Okay. So most of the nonlinear equations I'll give you guys will be pretty straightforward. For example, sine x, notice there's not a whole lot going on besides that 4. A quadratic, not a whole lot going on besides the initial x squared. So again, use your calculator if it helps. That's all I have for you guys today. The homework is the next worksheet. So we have 4 graphs. Make sure your name is on the worksheet when you turn it in. Worksheet is due Thursday by midnight. Have a great day. We'll talk to you guys soon.